So this is going to be part one of a 4-part series for the study guide for geometry. So this is part one covering all of our transformations, and this is going to cover questions 1 through 10. So for the first 4 questions, we're going to graph each figure and its image under the translation with the given rule and give the coordinates of the image. So the first one is a translation, which we know is just a slide. So we're taking our coordinates x, y, and moving it to x plus 5 and y minus 3. So when we add 5 to x, that means that I'm moving to the right 5, and then y minus 3 means down 3. So I'll move A first, so I'm going to count to the right 5, and then down 3, and that ends up right here, and that's A prime. If you can't tell, the origin is right here in the middle, so that is at -2, 0. B prime, 1, 2, 3, 4, 5, 1, 2, 3 is right here, and that is at 2, 3. And then C prime, 1, 2, 3, 4, 5, 1, 2, 3 is here, and that is at 3, -7. And then I'm going to go ahead and use my ruler to connect these. You should always use a ruler when you're graphing these. And there is my image. Okay, number 2 is another translation. So it's x minus 4 and y plus 6. So this time we're moving to the left 4 and up 6. And the order that you do that doesn't matter. You could count up first, then left, either way. And it doesn't matter which point you start with, so long as you make sure that you put them in the right place. I'm still going to start with L. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. There is L prime. Again, here is the origin, so that's at -3, 4. M prime should be here, and that's at -1, 5. There is P prime, so that's at -2, 0. And then here is N prime, and that's at 4, 3. So translation is just going to be a shift, left, right, up, down, or any combination of those. The figure should be the same size, the same shape, just shows up on a different part of the graph. All right, let's look at number 3. Q prime is at 5, 1, and it is the image of Q after Q has been reflected over the line y equals -x. And what are the coordinates of Q? If you have a little bit of trouble visualizing this, I would recommend that you use one of the graphs above. So Q prime is at 5, 1. So that would be right here. And the line y equals -x is this one. So if I put that there at my pen, I know it's a little thick, but we want to imagine that this point is going to flip over that line. So when that flips over, it's going to come down here, which means that my 1 and my 5 have swapped places, and in the third quadrant, they're both negative. So that's going to end up being at -1, -5. And if you have your graph, you can actually draw on it. I just didn't want to draw on top of that one for you, but Q started at -1, -5 to flip over my pen and end up at 5, 1. Okay, number 4, D prime is at 2, -10, and is the image of D after reflection over the y-axis. So the y-axis is our vertical axis, and when we're flipping from one side to the other, we remember that the y stays the same, and it's the x that changes. So if we were at 2, -10, that would be over here, and if that's going to flip over this y-axis, it's going to flip from here to there. So the only thing that's going to happen is my x is going to change to a negative, and my -10 is going to stay the same. So D was at -2, -10. Okay, Number 5. It says graph each figure and its image under a reflection over the given line. Give the coordinates of the image. So trapezoid, TRAP, has vertices. So we're going to go ahead and graph these. 2, 5 is here. And that's T. R is here. A is here. Did I miss something? I have no idea what happened here, guys, but this is definitely wrong. That is where P would have ended up being. And I have no idea what happened. But let's just go ahead and go with it. Let's just assume if I connect these and then T went to R, it's just going to look like a crazy shape. Let's just go with it and see what happens. There we go. No longer a trapezoid, just a funky little shape. So now, if we go ahead and reflect this over the x-axis, my line of reflection is right here in the middle. Let me grab my highlighter. So here is my line of reflection. Everything that's above it will drop below, and everything that's below it will drop above. So A is on the line of reflection, so A and A prime happen to be the same thing. R is going to go from above this to below this. So it started 3 above, now it's going to drop 3 below. So if we remember from our rules, the x coordinate stays the same, and the y coordinate becomes the opposite. So then the same thing is going to happen with P. P was at -5, -5. So now the x coordinate stays the same and the y coordinate flips. And then T, the x coordinate stays the same and the y coordinate flips. I'm so sorry that our shape got all messed up. I took this straight out of a review sheet, so I have no idea where that came from. I'm sure I had a typo here, but I'm more worried about you being able to get these coordinates correct than I am about the actual graphing of it. So I don't want you to worry too much about that. Okay, number 6 should be better. Let's take a look at that. So we're gonna start by graphing. S is here. T is here. U and V. This looks way better. So there is our parallelogram STUV. So now we are reflecting over the line x equals 2. If you recall, x equals is a vertical line that goes through the x-axis at 2. So here's the x-axis here, and that's where 2 is. So this is going to be a vertical line that goes like so. So when we flip this guy, we're just going to count from 1 point to the line and then keep going. So S is 1 point away from this line, it's 1 unit. So on the other side of the line, S prime will also be 1 unit. So that puts S prime at 1, 3. Let's see, let's do T next. So T is 1, 2, 3, 4 units away from the line of reflection. So then on the other side, 1, 2, 3, 4, and that's where T prime ends up, which is at -2, 6. And if you're noticing, the y values are not changing. So I know that U prime is going to have a y value of 3, and V prime is going to have a y value of 0 because that hasn't changed. We just have to figure out what the x value of U is. So when we flip this over, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, it's going to be right there. And that's -3, 3. and then v prime, going to end up at 0, 0. And so my parallelogram has flipped over. It's kind of facing the other direction, but it's still the same size. And, it's still a parallelogram. It's just a mirror image. All right. Let's move on to number 7. Oh, before we do number 7, we want the coordinate rule for each rotation. So I know 180 degrees is the easiest to remember because your coordinates stay in the same order, but they just both become the opposite, so negative x and negative y. The 90 degree one and the 270 degree one are a little bit harder to remember. They do both switch, but one of them is negative in 90 degrees and then the other one's negative in 270 degrees. If you're never sure, if you're ever not sure, imagine that you have a point in the first quadrant, right? Let's say it's at 2, 3, and I want to rotate it 90 degrees here. So I know that my y and my x are going to swap. So it's going to be 3, it was 3 then 2, so now it's 2 then 3, and that ends up here, okay? But in the second quadrant, the x value is negative, which means that for 90 degrees, the first thing has to be opposite, which means for 270, it's y comma negative x. So just one way that you could try to remember that, and if that doesn't work for you, that's totally fine. Just skip ahead. Okay. I'm going to go ahead and graph our square here, KLMN first, and then we can go about doing our rotation. All right, so this was a pretty easy one, KLMN. And then we're doing 270 degrees counterclockwise about the origin. 270 means that my y and my x flip, go in the different order, and then the second one is negative. So that means for this one, we should end up at 2, negative 2. For this one, we're going to swap. The 5 is going to come first, the 2 is going to come second, and the 2 is going to become negative. And then for n, the 2 is going to come first, the 5 is going to come second, and it's going to be negative. And if you're ever not sure, you should be able to figure out, if we're starting with our shape in the first quadrant, 270 degrees means 1, 2, 3. We're going to end up down here in quadrant 4. I know that in quadrant 4, my x values are positive and my y values are negative. So my points should reflect that, where the first value is positive and the second value is negative. So now all I have left to do is just to graph my final shape. So we're at 2, negative 2, and that's K prime. And then I'm at 5, negative 2, and that's L prime. 5, negative 5 is M prime, and then 2, negative 5 is N prime. And I know that these look like they would be a reflection here, but the important thing to notice is that if n were going to be reflected, n prime would show up here, but that's not n prime, that's L prime. So if you're given a question like that where it asks you what the, like to write the rule, or given a multiple choice option, which one is this, just don't get caught in that, seeing that, oh, you can just flip it over. They'll give you the coordinates on purpose so that you don't get tripped up by that. Okay, let's look at number 8. I'm going to go ahead and graph quadrilateral VWXY. Negative 6, comma 2 is V. All right, and then W is up here. Negative 2, 7 is X. And negative 2, 4 is Y. All right, and so for this one, 180 degrees. So that means that my order is going to stay the same, right? X then Y, but I'm going to make both of them opposite. So negative 6 is going to become positive 6, and positive 2 is going to become negative 2. And then we're going to be at 5, negative 6, 2, negative 7, and 2, negative 4. So when I graph these, I've got V prime, W prime, 2, negative 7 is X prime, and 2, negative 4 is Y prime. There we go. Okay, 2 more left for this. So now we've got a sequence of transformations where we have multiple things happening at the same time. So I'm going to go ahead and graph these, and we're going to go like one bit at a time. I believe that A was supposed to be at 2, negative 6, because that seems so high up. 1, 2, 3, 4, 5, 6. So let's go ahead and say, so yeah, A is supposed to be down here, and then B, and then C is at 6, and D. There we go. So here is our original shape. Again, sorry about that typo that I made. And so we've got two different things that have to happen. The first is a reflection over the line y equals negative 2. So y equals is a horizontal line that goes through the y-axis at negative 2. So that's there. And then we're going to translate. And when we translate, we know that x plus 2, y plus 5 means that we're going right 2 and up 5. So I'm going to do everything to point A first and figure out where A prime is going to be before I move on to the rest of my shapes. So the first thing we're going to do is take A and reflect it over this line. So it's 1, 2, 3, 4 units away. So that means that it would end up here. And then I have to take that and move it to the right 2 and 1, 2, 3, 4, 5. So it's going to end up A prime is going to be up here. That's at 4. And then 1, 2, 3, 4, 5, 6, 7. So A prime is at 4, 7. Now let's do B. So it's 1, 2, 3, 4, 5 units away. So 1, 2, 3, 4, 5. And then right 2 and up 5. So that's B prime. That's going to be at 7, 8. Oh, and now we're going to move off of the grid because I messed up again. 1, 2, 3, 4, 5, 6, 7, 8 units away. So then 1, 2, 3, 4, 5, 6, 7, 8 units away. And from here, I can tell you that C is at 1, 2, 3, 4, 5, 6, comma, 1, 2, 3, 4, 5, 6. So C was at 6, 6. When I have to move that right 2 and up 5, if I'm taking 6, 6, I'm going to add 2 to X and add 5 to 11. So C prime is going to end up at 8, 11, which is going to be, you know, somewhere up here. And then for D, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then I would move that right 2. So let's see, that's at 3, 5. So right 2 and up 5 We'll put that right about here. So it would end up here. Oh, my C prime got a little messy. So this is our final shape. I promise that I've already done the test and this doesn't show up on there. I promise that it fits on here. I don't know how that happened, but you know, mistakes are made. Everything's good. Let's focus on the last problem and then we can move on. So number 10 is our last transformation problem. So we have our triangle LMN. Here is my origin. I'm just going to mark that so it's easy for me to see. So L is at -3, -2. M is at -2, -7. And N is at -8, -5. Okay, we are going to rotate this counterclockwise about the origin 270 degrees, and then we're going to go right 7 and down 2. So I actually want to do this the coordinate way. We'll do our 270 degrees in the middle, and then we'll do the right 7 and then down 2. So my coordinate rule for 270 degrees is that you switch the order and make the second one opposite. So the -2 comes first and the second one becomes a +3. Then I just have to add 7 to the first one and subtract 2 from the second one. So my L prime should end up at 5, 1. Let's try M. So my -7 comes first, my 2 comes second, and is opposite. Then I add 7 to X and subtract 2 from Y. So M prime actually ends up right there at the origin. Last one is -8, -5. So N, -5 comes first, 8 comes second and is positive. Then I'm going to add 2 to X, or I'm sorry, add 7 to X to get 2, subtract 2 from 8 to get 6. So 2, and here is N prime. And there is my final shape, N prime at 2, 6. You also could have just performed the rotation first and graphed that on here, then counted on the graph to get to there. But your final shape should end up at L prime 5, 1, M prime 0, 0, N prime 2, 6. Wonderful.